Hello and welcome to a demo of Batfish Enterprise. My name is Ratul and I will show you how you can secure your AWS network even if it is spread across multiple accounts. If your company has sizable presence in AWS, chances are that deployment is spread across multiple accounts. Say one for HR, one for IT, and one for finance. When it comes to securing connectivity for such deployments, you have two problems. The first problem is connectivity to and from the world outside of AWS. In other demos, I showed you how Batfish can let you do that easily. But your problems do not end there. Your different accounts also need to talk to each other. And for performance or cost, this should happen without leaving AWS. So, you may set up transit gateways between VPCs to enable that connectivity, or you may set up VPC peerings for that. Once you are done, the world becomes complex and you don't have good visibility into how various resources connect and which resources can talk to each other. For example, if an instance were to get compromised in one account, do you know which resources in other accounts are at risk? Batfish makes such east-west security analysis almost trivial, and I will give you a demo of that in this video. With this capability, you can be rest assured that your network is fully secure and the blast radius of a mistake or compromise is properly contained. This is the Batfish Enterprise dashboard. We see here three VPCs, one for HR, one for IT, and one for finance. Two of the VPCs are in the same region and connected via the transit gateway. The finance VPC is in a different region and it connects to the IT VPC using a VPC peering link. In this setup, each VPC is in a different account. And if we go to the settings page, we can see that Batfish Enterprise is pulling from each of the accounts and configured to pull from these regions that we see here. You can add as many accounts as you like, and Batfish Enterprise will pull from each of them and present a unified view of your AWS deployment as you see here. To understand the full security posture of this deployment with respect to any vantage point, we can use the Nmap capability of Batfish. By default, this capability uses Internet as the starting point. Batfish Nmap shows all ports reachable from the source after taking into account all possible packet headers and all elements along the path such as routing tables, network ACLs, and security groups. What we see here is that inside VPC HR, only port 80 is accessible from the internet, and inside VPC IT, only SSH is accessible on TCP and port 500 UDP corresponding to our VPN servers, and ICMP echo request is accessible here. So that seems good. What we also see is that nothing inside VPC Finance is accessible directly from the internet. Now, suppose you want to validate the security posture with respect to another source. So let's pick one together. Let's focus here. This is our jump subnet inside the IT VPC. And what is this test server doing here? So since this is a highly protected subnet that has wide-ranging access to resources across all of our accounts, we want to make sure that this test server has been locked down. To test that, we will enter that in the Nmap form as the source, run it, and notice that I did not have to log into the instance or even send a single packet. And I got back a report which shows all the access that this test server has. So we see it can reach the internet, maybe that's okay, but it can also reach a lot of resources inside AWS deployment. It can reach the West region as well as the East region. So let's dig deeper into the East region and things are getting interesting. We see that it can reach the database subnet we have in the Finance VPC. And not just that, it can actually reach the database server on MySQL port. Now that seems really wrong. So to understand why that happens, we can click here and we come to a page that shows the Batfish Enterprise traceroute. This traceroute view shows in detail how the packets get from this source to the destination. And along each hop, it shows you all the routing elements encountered, routing tables, network ACLs, or security groups. So in this destination, for instance, we say the packet entered here, then it passed through a security group. Now, if you're curious, why did the security group let this packet in from a test server and why it was not dropped? We can click on the test filters link and we get here, and this exactly shows why the packet made it across. It made it across because we have a security group rule called MySQL Access, which matches on TCP ports 3306, and all sources from this subnet are allowed. And this subnet happens to be our jump subnet. Thus, this analysis is revealing a vulnerability in our security practices across accounts. Either we should not have whitelisted all resources in that subnet, and only whitelist specific servers in the subnet, or we shouldn't have placed a test server in the trusted subnet without limiting its access to the outside world. So thus this is a situation where an error in one account opens up a security hole in another account. Thanks for watching this Batfish Enterprise demo where I showed you how you can comprehensively detect and neutralize network security threats in your AWS deployments, even when that deployment spans multiple AWS accounts. Want to see this in action in your own infrastructure? Go to that URL to get your own free trial of Batfish Enterprise. Thank you. Bye now.